So here we see the topic, that is beta and gamma functions. So we have x factorial is equal to x plus n factorial upon x plus 1 n for integers x comma n greater than or equal to 0, where an denotes that Pachymer's function or shifted function defined as an is nothing but a product of a plus 1 up to a plus n minus 1 for n greater than 0. And here we have a0 is equal to 1. Here a is real or complex number. Also we write x factorial equal to limit as n tends to infinity n factorial into n raised to x divided by x plus 1 n. So note that here pi of x is equal to limit as n tends to k tends to infinity k factorial into k raised to x divided by x plus 1 k, defined for all complex numbers x not equal to minus 1 minus 2 and so on. And pi of n is equal to n factorial. Then we have definition of that gamma function. So for real number x greater than 0, the gamma function is defined as gamma of x is equal to integration from 0 to infinity t raised to x minus 1 into e raised to minus t dt. The above integral is also known as Eulerian integral of second type. Now here we have example that it shows that gamma 1 is equal to 1. So we know by definition of gamma function, gamma x is equal to integration from 0 to infinity t raised to x minus 1 into e raised to minus t dt. So therefore gamma 1 equal to integration from 0 to infinity t raised to 1 minus 1, that is 0, into e raised to minus t dt. So it is integration from 0 to infinity e raised to minus t dt. So we know that integration of e raised to minus t is e raised to minus t upon minus 1, limits of integration from 0 to infinity. So this is equal to upper limit is infinity. So e raised to minus infinity upon minus 1 minus lower limit is 0. So e raised to 0 upon minus 1. So we know e raised to minus infinity is 0. So this one is 0 minus minus plus e raised to 0 is 1. So it is 0 plus 1, that is equal to 1. Hence we have gamma 1 is equal to 1. Then we have next important result, that is here we have to show gamma 1 half is equal to under root of pi. So by definition of that gamma function, gamma of x is equal to integration from 0 to infinity e raised to minus t into t raised to x minus 1 dt. So therefore put x is equal to 1 half. So we get gamma 1 half is equal to integration from 0 to infinity e raised to minus t into t raised to 1 half minus 1 dt. That is integration from 0 to infinity t raised to minus half into e raised to minus t dt, or it is integration from 0 to infinity e raised to minus t upon t raised to half dt. So here we use substitution, that is we put here t raised to half is equal to I. So from that we have t is equal to I square. So dt is equal to 2I dy. So limits of integrations remains same here. So therefore gamma 1 half becomes gamma 1 half equal to integration from 0 to infinity integration from 0 to infinity e raised to minus y square upon y into 2I dy. So this y get cancelled. So therefore gamma 1 half is equal to 2 times integration from 0 to infinity e raised to minus y square dy. Also we replace the variable y by x, so that we get gamma 1 half is equal to 2 times integration from 0 to infinity e raised to minus x square dx. Now we take the product of these two equations 1 and 2. So left hand side is gamma 1 half into gamma 1 half is equal to product of these two right hand side. So it is 2 times integration from 0 to infinity e raised to minus y square dy into 2 times integration from 0 to infinity e raised to minus x square dx. So therefore gamma 1 half square equal to 4 times double integration from 0 to infinity e raised to minus x square plus y square dx dy. Again here we have that substitution. So put x square plus y square equal to r square. So here we have the polar coordinate, that is x is equal to r cos theta, y is equal to r sin theta. So dx dy is equal to r dr d theta. Since r is running from 0 to infinity, here theta is running from 0 to pi by 2. So therefore we have gamma 1 half bracket square equal to 4 times integration from 0 to pi by 2 into integration from 0 to infinity e raised to minus r square into r dr d theta. Again here we use substitution, that is we replace this r square by p. So whenever r square is equal to p, we have 2r dr is equal to dp. This one is dr. So 2r dr is equal to dp. So from that we have r dr is equal to dp upon 2. So again limits of integrations remain same. So therefore gamma 1 half square is equal to 4 times integration from 0 to pi by 2, integration from 0 to infinity, e raised to minus p into r dr as well dp upon 2. So this dp upon 2 into d theta. So this is equal to 4 divided by 2, that is 2. So it is 2 times integration from 0 to pi by 2 into integration from 0 to infinity e raised to minus p dp d theta. So integration of e raised to minus p is e raised to minus p upon minus 1. Limits of integration from 0 to infinity. So upper limit is e raised to minus infinity, that is 0, and minus minus plus e raised to 0 is 1. So it is 0 plus 1 d theta. So this is equal to 2 times integration of 1 is theta. So here we have upper limit is pi by 2, lower limit is 0. So this is 2 times pi by 2 minus 0, that is equal to pi. So this is the value of that gamma 1 half square. So taking the square root here, we get gamma 1 half is equal to under root of pi. Then we have next example, that is prove that gamma n plus 1 is equal to n times gamma n. So by definition we have gamma x is equal to integration from 0 to infinity e raised to minus t into t raised to x minus 1 dt. So here we put x is equal to n plus 1. So therefore gamma n plus 1 is equal to integration from 0 to infinity e raised to minus t into t raised to n plus 1 minus 1 dt. So this is equal to integration from 0 to infinity e raised to minus t into t raised to n dt. So here we solve this integration by parts. So this is equal to t raised to n into integration of e raised to minus t is e raised to minus t upon minus 1, limits of from 0 to infinity, minus integration derivative of the t raised to n is n times t raised to n minus 1 into e raised to minus t upon minus 1 dt. So this is equal to 0. This upper limit is infinity, e raised to minus infinity is 0, and lower limit is 0. And so here we have t is 0. So this is also 0. So value of this integral is 0, minus minus plus n times integration of integration from 0 to infinity of e raised to minus t into t raised to n minus 1 dt, and that is nothing but the our gamma n. So therefore gamma n plus 1 is equal to n times value of this integration is gamma n. Then we have definition of that beta function. So beta function is defined as it is the integral for real numbers x and y. So beta xy is equal to integration from 0 to 1 t raised to x minus 1 into 1 minus t raised to y minus 1 dt. Here t is any variable. So note that here beta of xy is equal to beta of yx. By just using substitution, put t is equal to 1 minus p in this above integral. Then we have very important theorem, that is nothing but the relationship between beta and gamma functions. So here we have that theorem, that is prove that beta mn is equal to gamma m into gamma n upon gamma m plus n. So we have by definition of that gamma function, gamma y is equal to integration from 0 to infinity t raised to y minus 1 into e raised to minus t dt. So here we have substitution, put t is equal to az. So from that dt is equal to a dz. Again limits of the integration remains same. So therefore this gamma y is equal to integration from 0 to infinity. Here t is equal to az. So this is az raised to y minus 1 into e raised to minus az into value of dt is a dz. So this is equal to integration from 0 to infinity a raised to y minus 1 into z raised to y minus 1 into e raised to minus az into a dz. So this is integration from 0 to infinity. A raised to minus 1 into a is a raised to y into z raised to y minus 1 into e raised to minus az dz. Here we replace this z by t. So just change of variable. So this gamma y is equal to integration from 0 to infinity e raised to y into t raised to y minus 1 into e raised to minus at dt. And again this replace a by z. So that gamma y is equal to integration from 0 to infinity z raised to y into t raised to y minus 1 into e raised to minus zt dt. So this is the value of gamma y. Now multiply both sides of this expression by e raised to minus z into z raised to x minus 1. We get left hand side is gamma y into e raised to minus z raised to x minus 1 equal to integration from 0 to infinity z raised to y t raised to y minus 1 into e raised to minus zt into e raised to minus z into z raised to x minus 1 dt. So by simplification, the right hand side is integration from 0 to infinity t raised to y minus 1 into z raised to x plus y minus 1 into e raised to minus zt into e raised to minus z is e raised to minus z into bracket t plus 1 dt. Now integrate here both sides with respect to z between the limits 0 to infinity. So therefore we have gamma y into integration from 0 to infinity e raised to minus z, z raised to n, x minus 1 dz equal to double integration from 0 to infinity t raised to y minus 1 into z raised to x plus y minus 1 into e raised to minus z into t plus 1 dt dz. So here we separate terms from right hand side. On the left hand side, this value of this integral is nothing but the gamma x. So therefore left hand side is gamma y into gamma x is equal to integration from 0 to infinity t raised to y minus 1 into integration from 0 to infinity. Here in the inside integral we have functions of z only. So we have z raised to x plus y minus 1 into e raised to minus z into 1 plus t dz and dt. So here we use substitution, that is put z into 1 plus t is equal to p. So whenever z into 1 plus t is equal to p, we have dz is equal to dp upon 1 plus t. Limits of integration remain same. So therefore gamma x into gamma y is equal to integration from 0 to infinity t raised to y minus 1 into integration from 0 to infinity value of z is here p upon 1 plus t. So this one is p upon 1 plus t raised to x plus y minus 1 into e raised to minus p and value of dz is dp upon 1 plus t, and this one is dt for outside integral. So this is equal to integration from 0 to infinity over t raised to y minus 1 divided by 1 plus t raised to x plus y minus 1, and this is a 1 plus t raised to 1, so this becomes 1 plus t raised to x plus y into integration from 0 to infinity p raised to x plus y minus 1 into e raised to minus p dp, but this is nothing but the integral, that is gamma x plus y. So this is gamma x plus y dt. So our left hand side is gamma x into gamma y. So this gamma x into gamma y is equal to gamma x plus y into integration from 0 to infinity t raised to y minus 1 upon 1 plus t raised to x plus y dt. But value of this integral is beta xy. So our right hand side is gamma x plus y into beta xy, because beta xy is equal to this integral, that is integration from 0 to infinity t raised to y minus 1 upon 1 plus t raised to x plus y dt, that we prove in our next result. So thus from this one we have beta xy is equal to gamma x into gamma y divided by gamma x plus y. So this is the relationship between that beta function and gamma function. So our next result is the proof of this result, that is show that beta xy is equal to integration from 0 to infinity t raised to x minus 1 divided by 1 plus t raised to x plus y dt. So we have beta xy, that is the beta function, is equal to integration from 0 to 1 z raised to x minus 1 into 1 minus z raised to y minus 1 dz. Now we use substitution here, put z is equal to t upon 1 plus t. So therefore dz is equal to, by u upon v formula, dz is equal to 1 upon 1 plus t bracket square dt. As z is equal to t upon 1 plus t, we have 1 plus t into z is equal to t. So from that we have to find the value of t in terms of z. So from that we have z plus zt is equal to t. So z is equal to t minus zt, that is t into 1 minus z. So from that value of t is equal to z upon 1 minus z. Again limits of integration, at z is equal to 0, t is 0, and at z is equal to 1, if you put z is equal to 1 here, this becomes infinite. So t is equal to infinity. So from that we have value of beta xy is integration from 0 to infinity t upon 1 plus t raised to x minus 1 into 1 minus z, that is 1 minus t upon 1 plus t raised to y minus 1 into value of dz is dt upon 1 plus t bracket square. So that is equal to integration from 0 to infinity t raised to x minus 1 upon 1 plus t raised to x minus 1 into this value is 1 upon 1 plus t raised to y minus 1 into dt upon 1 plus t square. So the denominator is 1 plus t raised to x minus 1 into 1 plus t raised to y minus 1 into 1 plus t bracket square. This is 1 plus t raised to x plus y, and numerator is t raised to x minus 1. So this is equal to integration from 0 to infinity t raised to x minus 1 upon 1 plus t raised to x plus y dt. So this is the answer. Note that here beta xy is equal to integration from 0 to infinity t raised to x minus 1 upon 1 plus t raised to x plus y dt. So here we can change the variable x by y. So this is equal to integration from 0 to infinity t raised to y minus 1 upon 1 plus t raised to x plus y dt. So here we can this change the variable x by y, or we can interchange y by x, and this is the value equal to that gamma in terms of gamma function gamma x into gamma y upon gamma x plus 1. Then we have next result, that is prove that integration from minus infinity to plus infinity e raised to minus x square dx is equal to under root of pi. So left hand side is integration from minus infinity to plus infinity e raised to minus x square dx is equal to 2 times integration from 0 to infinity, because this function is even function. So it is 2 times integration from 0 to infinity e raised to minus x square dx. Here we use substitution, that is put x square is equal to t. So from that we have x is equal to t raised to half. So dx is equal to 1 half times t raised to minus half dt. Limits of the integration remains same. So therefore left hand side becomes 2 times integration from 0 to infinity e raised to minus t into value of dx is 1 half t raised to minus half dt. So this 2 to get cancelled here. So this is equal to integration from 0 to infinity e raised to minus t into t raised to minus half. T raised to minus half we write it as 1 half minus 1, and here we use the definition of gamma function. So this is nothing but the gamma 1 half. So this is equal to gamma 1 half, because we know that gamma of x is equal to integration from 0 to infinity e raised to minus x into e raised to minus t into t raised to x minus 1 dt. So here by definition of gamma function, value of this integration is gamma 1 half, and we know that value of gamma 1 half is under root of pi. Hence the value of this integral, that is left hand side integration from minus infinity to plus infinity e raised to minus x square dx is equal to under root of pi. Then we have next result, that is important one, that is evaluate integration from 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta. So let I is equal to given integral, that is from 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta. Now here we substitution, put sin square theta is equal to z, but sin square theta is 1 minus cos square theta. So therefore 1 minus cos square theta is equal to z. So from that we get value of cos square theta is equal to 1 minus z. So by differentiation we have differentiation of this one is 2 sin theta cos theta d theta is equal to dz, that is sin theta cos theta d theta is equal to dz upon 2. Now limits of the integration, here theta is running from 0 to pi by 2. So whenever theta is equal to 0, z is equal to 0, and whenever theta is equal to pi by 2, z is equal to 1, because sin pi by 2 is 1. So here z is running from 0 to 1. So the given integral I becomes integration from now the given integral we can rearrange in the terms I is equal to integration from 0 to pi by 2 sin raised to p theta we write it as sin raised to p minus 1 theta into sin theta, and cos raised to q theta we write it as cos raised to q minus 1 theta into cos theta d theta. Again this one sin raised to p minus 1 theta we write it as sin square theta raised to p minus 1 by 2, and cos raised to q minus 1 theta we write it as cos square theta raised to q minus 1 by 2 into sin theta cos theta d theta. So this is equal to, by using substitution, here limits of the integration are changed from 0 to 1. Sin square theta is z, so it is z raised to p minus 1 by 2. Cos square theta is 1 minus z, so this term becomes 1 minus z raised to q minus 1 by 2. And value of sin theta cos theta d theta is dz upon 2. So this integral equal to 1 half integration from 0 to 1 z raised to p minus 1 by 2 into 1 minus z raised to q minus 1 by 2 dz. But p minus 1 by 2 we write it as equal to p plus 1 by 2 minus 1. So here we replace this p minus 1 by 2 by p plus 1 by 2 minus 1. So the integral becomes I is equal to 1 half integration from 0 to 1 z raised to p plus 1 by 2 minus 1 into 1 minus z raised to q plus 1 by 2 minus 1 dz. So here use the definition of that beta function. So this is nothing but this integral is beta p plus 1 by 2 q plus 1 by 2. So thus the value of the given integral is equal to 1 half beta p plus 1 by 2 q plus 1 by 2. That is integration from 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta is equal to 1 half beta p plus 1 by 2 into q plus 1 by 2. But we know the relationship between that beta and gamma function. So by using that, we have beta p plus 1 by 2 into q plus 1 by 2 is gamma p plus 1 by 2 into gamma q plus 1 by 2 divided by sum of these two, that is gamma p plus 1 by 2 plus q plus 1 by 2. So that is equal to value of the integral is equal to 1 half gamma p plus 1 by 2 into gamma q plus 1 by 2 divided by p plus q plus 2 upon 2. Then we have next example, that is prove that integration from 0 to pi by 2 sin raised to 2x minus 1 theta into cos raised to 2y minus 1 theta d theta is equal to gamma x into gamma y upon 2 times gamma x plus y. Again let I is the given integral. So put here sin square theta is equal to z. So 1 minus cos square theta is z. So cos square theta is equal to 1 minus z. So from that, by differentiation, 2 sin theta cos theta d theta is equal to dz. So sin theta cos theta d theta is equal to dz upon 2. Same as in previous example, limits of the integrations are changes from 0 to 1. So therefore given integral becomes I is equal to here we have the sum arrangement again. I is equal to integration from 0 to pi by 2 sin raised to 2x minus 1 theta. We write it as sin raised to 2x minus 2 theta into sin theta, and cos raised to 2y minus 1 theta. We write it as cos raised to 2y minus 2 into cos theta d theta. So this is by again adding the term, it is 0 to pi by 2 integration from 0 to pi by 2 sin square theta raised to 2x minus 2 upon 2, that is x minus 1 into cos square theta raised to y minus 1 into sin theta cos theta d theta. But value of this one is z, that is sin square theta is z and cos square theta is 1 minus z. So this is integration from 0 to 1 z raised to x minus 1 into 1 minus z raised to y minus 1 into value of sin theta cos theta d theta is dz upon 2. So this is equal to 1 half integration from 0 to 1 z raised to x minus 1 into 1 minus z raised to y minus 1 dz. But by beta function, this is the value of beta xy. So the value of the integral is 1 half beta xy, but we know that beta xy is gamma x into gamma y upon gamma x plus y. So thus value of the given integral is 1 half gamma x into gamma y upon gamma x plus y. Then we have next important result, that is nothing but known as Euler's reflection formula. So in that we have to show gamma x into gamma 1 minus x is equal to pi upon sine pi x. So that real part of that x is lies between 0 and 1. So we know that beta of xy is equal to gamma x into gamma y upon gamma x plus y. Now put here y is equal to 1 minus x. So therefore beta x comma 1 minus x is gamma x into gamma 1 minus x divided by gamma x plus 1 minus x, that is gamma 1. But value of gamma 1 is 1. So here denominator becomes 1. So therefore beta x comma 1 minus x is equal to gamma x into gamma 1 minus x. So that is gamma x into gamma 1 minus x is beta x comma 1 minus x. But by definition of that beta function, value of this beta is equal to integration from 0 to 1 t raised to x minus 1 into 1 minus t raised to 1 minus x minus 1 dt. So this is equal to integration from 0 to 1 t raised to x minus 1 into 1 minus t raised to minus x dt. So that is equal to integration from 0 to 1 t raised to x minus 1 upon 1 minus t raised to x dt. Now here with substitution, that is t upon 1 minus t is equal to u. So from that we have t is equal to 1 minus t into u, that is u minus u into t. So from that we get value of t in terms of u as t is equal to u upon 1 plus u, and 1 minus t is equal to 1 upon 1 plus u. So from that we get dt is equal to, by u upon v formula, dt is equal to that is 1 upon 1 plus u bracket square du. Limits of the integration, they are from 0 to infinity. So from that we have gamma x into gamma 1 minus x equal to integration from 0 to infinity u upon 1 plus u raised to x minus 1 divided by 1 upon 1 plus u raised to x into du upon 1 plus u bracket square. So by collecting all the terms of 1 plus u, the power becomes that is 1. 1 plus u raised to x minus 1 divided by 1 plus u raised to x, and this 1 plus u bracket square, this becomes only 1 plus u. So this is equal to integration from 0 to infinity u raised to x minus 1 upon 1 plus u du. But by complex variable method, value of this integral, that is integration over closed contour C of omega raised to x minus 1 upon 1 plus omega d omega is equal to pi upon sine pi x. So from equation 1, we have gamma x into gamma 1 minus x is equal to pi upon sine pi x.